Next we're going to look at some core 4 trig. We're going to start with the trig addition formulae, and we're going to use them to solve equations and to prove some trig identities. These formulae are for sine A plus B, sine A minus B, cos A plus B, cos A minus B, tan A plus B, and tan A minus B. Now obviously this doesn't require an addition formula to solve, because we know that sine 30 plus 60 is sine 90, which equals 1. We also know that it's not the same as this. If we expand out sine 30 and sine 60, we should know that sine 30 is a half, and we should know that sine 60 is root 3 over 2. And you can see clearly that's over 1. In fact, it's approximately 1.37. So before we start, just be clear that this doesn't work. We can't simplify as we do in algebra. These are the formulae we need. I've put a PowerPoint on Moodle so you can see how the formulae are derived, but for now I'm just going to give you what's written in the formula booklet. And here you've got sine A plus B, if you follow the bit at the top, equals sine A cos B plus cos A sine B. If you want sine A minus B, you follow the bottom and you get sine A cos B minus cos A sine B. You can also see in a similar way the formulae here for cos A plus B and cos A minus B, and tan A plus B and tan A minus B. As I say, they are given in the formula booklet, so be clear how to use them. Use the top signs or both bottom signs. Notice that in the cos one, the signs are opposite, so you get cos A plus B as cos A cos B minus sine A sine B. So as I said before, we can use them to solve. We can also use them to prove. You'll notice that all 6 of those formulae are identities. They're true for all values of x and y. And they're often also used to prove other identities. So we've got this identity here. Now, generally speaking, if you've got something like this, the first thing you would do is expand out where you've got the need for an addition formula. So expand out sine x plus y and sine x minus y. Like that. The first 2 formulae. If you get rid of the bracket, you can now see you've got sine x cos y plus cos x sine y minus sine x cos y, so those 2 are going to cancel, plus cos x sine y. So those 2 cancel, and you're left with 2 cos x sine y, which is the right hand side. Okay, have a go at this one yourself. Think of it in a similar way. Don't forget that cot is cos over sine. So have a go at that. See this, expand it. Pause the presentation and see if you can do it yourself. Okay, that's what you should have got. The first step is to expand out where you see the need for the addition formula, like I suggested before. So we use the second sine one, the sine A cos B minus cos A sine B one. In this case we've got alpha and beta for our A and B. Once you've done that, you can split these two fractions, and you can see here that the sine alphas will cancel, the sine betas will cancel, like so. And because we know that cot beta is cos beta over sine beta, and cot alpha is cos alpha over sine alpha, then we can reduce it to what we're aiming for on the left hand side. So we've used the expansion of that part on the right hand side in order to prove that this identity is true. Okay, here's another one to have a go at. Again, pause the presentation, have a go, and then I'll show you it when you're ready. Okay, so this is the way forward here. Here we've got two requirements of addition formula, and you can see they've been expanded out here. There's the first one, the sine x plus 30 degrees. So you get sine x cos 30 plus cos x sine 30. X is your A, 30 is your B from the formula. Similarly on this side, we use the cos one. Remember the sign's different, so we've got that minus sign there. Now we should know the values of cos 30, root 3 over 2, sine 30, a half, cos 60, a half, and sine 60, root 3 over 2. And you can see there by using those values how we managed to get to this. Put the values in, multiply by 2, we multiply both sides by 2 to get rid of the halves. And then if we gather like terms, sine x terms on the left, cos x terms on the right, we end up proving what we set out to. It then says hence solve that equation. Well, all we need to do for that is turn the sine x cos x into a single ratio, and the obvious thing to do there is to divide the sine x term by the cos x term, giving us tan x. So we get sine x over cos x, and divide by 7 root 3, and we get 5 over 7 root 3. And then it's just tan minus 1 that. And we're looking for values between minus 180 and 180. So if the principal value is 22.4, if we add 180, it will be too much, won't it? Be 202.4. But if we subtract 180, we get minus 157.6. Okay, if you were successful with those two exam style questions, then you're ready for the lesson. If not, perhaps you need to go back over it or look at this topic on My Maths before the lesson.